Welcome back to another video. Today we're going to be taking a look at an iPhone 14 Pro Max that has seen better days. As you can tell, this screen is completely toast, along with the back. But today we're going to focus mainly on the display because it's busted. And as you might be aware, there are plenty of different qualities of displays out there. And we're going to be talking today about an AQ7. Let's get started. The AQ7 in-cell display is a 120Hz refresh rate screen that has an LCD panel and is IC transfer compatible. Now what does that mean? It means that it has the ability to accept the display IC from the original display, and there has been many generations, including ones that are soldered directly onto the flex, a separate tag on flex, or in this case, a new version where the IC is soldered in the same area from where it's removed on the original display. And obviously the display doesn't even need that. You can just use the display as is, and replacing the display with this is going to save quite a bit of money, as upgrading from an LCD panel to an OLED panel is going to 3 or 4x the cost. And if you're looking at going up to a genuine, you're 10xing even more the cost from an LCD. Of course, I prefer to see the genuine displays on the phones. Some people don't want to pay for that, so I completely understand. Now, after getting the broken display off, the first thing that I did was simply transfer over the proximity sensor assembly. It's 2 screws, 1 bracket, and a little bit of prying, and it's transferred over. Now, let's quickly go under the microscope so I can show you how to remove the display IC. Alright, one of my favorite tools for this is this little hook tool that I have. I use it in many different applications, but it really works well for one of these. I'm going to start with my hot air set at 200 Celsius with a mid airflow. And obviously I'm not worrying about this display. And I'm just going to cut at some of the... I just want to go around and get rid of all of the underfill that I can possibly get rid of on the sides. And I'll take the temperature up to a quick 350. We'll keep the air moving around it. And then everything should get up to temperature really quickly. And I'll go under and pop it off just like that. Alright, so we'll get it clamped up so that it doesn't want to move on us. And take a little bit of flux. We'll take a soldering iron, a little bit of solder on the end. And I'm going to go around the IC. And what we've got to do is remove the underfill. And you can kind of gently scrape at it. And the iron will kind of skate across the surface. And you'll feel when you've removed any of the underfill, or if you've missed a spot. It'll be pretty obvious with the iron, the way that it feels. And I'm just going to go around all of the edges and make sure that all of the underfill is gone. If we don't have all the underfill gone, then it's going to create a high point, and the chip won't sit flush on the flex. And we need it to be completely flush. We'll do a little bit of cleanup, but first I'm going to add more flux before we go to the cleanup. And I'm going to come in with some solder. And what I'm going to do is add solder to all of these pads and get a nice uniform array of solder balls on all of the pads. Just skating the iron across and it'll deposit an equal amount of solder on all of the pads. Now I'll take some isopropyl alcohol and some Q-tip or a cotton swab, and we'll clean up the chip, all the sides. And that way we're left with this perfect IC. Now there are some spots where you can start to see some of like the almost like some copper come through, but none of it is exposed except for maybe a teeny tiny bit there to the point where it would receive solder. That's not shiny enough. It still has that layer of almost like oxidation on it. So I'm not going to worry about using any solder mask, but if I did see a lot of that one speck there, you can see where it's nice and gold. If I see more of that, then I would apply some, but otherwise this chip is ready to install on this type of display. I don't have to reball it more than this. Now you'll notice the back of this chip says IC transferable. Basically what that means is that if you lift up this chip and just peel up this little cover, you will see the solder joints. And take a second to clean off this adhesive. You can do this by simply rolling something like a screwdriver
over the top of it. You want to get rid of all of the adhesive, otherwise, again, just like the underfill, it'll create a high point. So if you do that, you'll be able to kind of just go over and dab off all of the adhesive, just like that. Now I'm going to come under it real fast and gently lift up. There's a metal plate behind the flex that helps keep it nice and flat for the IC, and there's some adhesive that holds it to the back of the flex. And obviously you don't want to bend it in the process, you got to keep it nice and straight. Because what I like to do is create a nice little area for some Captain tape to kind of go over and shield the rest of the area. And then I take one last piece of Captain tape and we're going to close off that little hole. And you'll notice that there are some missing joints here. Those are just not important, so the display doesn't need them. Take a little bit of flux and we're just going to cover the whole flex with it. This will prevent the solder from getting any layer of oxidation on it when it's getting up to temperature, making it easier for the IC to flow to it. We've got the dot in this corner, which is a great indicator of where the dot needs to go from the display IC, which is obviously in this corner. So we'll rotate this around and then we'll line it on up. Take out our hot air and put it at about 300 Celsius and bring down my airflow quite a bit, and we'll warm up the area and we'll heat it up. And we'll see it snap into place like that. And then what I like to do is just give it one little nudge while it's at temperature, and we'll let things cool down. Alright, we'll peel off the Captain tape. We'll feed it back through that hole. We'll line up the display IC and compress it against the back of the display. Looking at it from the side, we could admire the solder balls, make sure everything looks good, and then we can go test it.
Alright, we'll go ahead and turn it on now that it's connected. Touch works, and as you can see, when we look at the settings, the only thing that it's not recognizing is that rear camera. So that's something that still needs to be fixed, but this display is now good to go. And most people can't even tell the difference between an OLED and an LCD from the outside. If you have any questions, leave them in the comments below. If there's something that you'd like to see in a future video, let me know as well. Thanks a ton for watching. We'll see you in the next video.